Hi, welcome everyone. I'm Yang Zuji from Amazon Redshift. I'm product manager. I'm so excited to meet all of you today. And we will dive into the modern data architecture and discover how to leverage data sharing to scale your data in analytics and also enhance the data collaboration within your organization. At the same time, how to ensure the security in data sharing. Today, I will speak with my colleague, Saurabh Bhatini, and he is a principal big data architect from AWS, and also our customer representative, Jamie Johnston. He is a data and analytics strategic advisor from Occidental. Here's the agenda, and we will start by examining the challenges, the common challenges our customers have from data sharing and during the process about the security in data sharing. And next, we will explore what AWS offers to overcome these challenges and also having you to collaborate with your data. Then Jamie will walk us through the real-world use case from Occidental, how they solve these data sharing challenges by leveraging AWS solutions. And then we will also have the third-party data sharing and collaboration solutions offered by AWS, and that will be Saurabh talking through that. All right, so data is important, and almost all our customers are well known about that. And they treat data as a key enabler, and they have invested in data more and more. From our survey from multiple sources, we find 82% of our organization have appointed a chief data officer. And 94% organization, they have increased their investments in data-driven initiatives. Customers who have successfully achieved the data-driven initiatives, they realize up to 20% revenue growth. However, not all these investments are successful. We find that only 1 in 4 organizations they have been able to complete their journey to becoming data-driven. Why is that? Now let's look at some challenges in this journey. The challenges come from 3 aspects. During the process, the customer involve their data and they find the requirements more complex. The first is data silos. Because the data is often fragmented into multiple repositories, and the customer need to have an additional ingestion cost to make sure the silos can work together. And these silos normally lack of the engine interoperability to meet the increased complex use cases. The second challenge comes from the data copies. Because the data is dispersed, and you need to copy the data from another. And whenever there's some model changes, let's say you update your column name, then you need to update everywhere, or you will lose this synchronization between your data. And then it will lead to reduced analytics accuracy. The third challenge is the fragmented governance. Because different data repository, it will have duplicated data access control in different environments. How do you make sure this different access control is synchronized, and whenever you access the data, you will gain the same access? It's very hard if you don't have the native support of data sharing from AWS, like your data environment. So all these challenges underscore the need for modern, integrated approach to data management. So AWS offers some solutions for this, but this is overview what we want to address. The first is AWS wants to enable the user to efficiently discover and locate the right data sets, and breaking down the data silos and fostering quicker decision making. Second is we want to minimize the delay so you can access your data in real time without the latency. And the third is we want to have the robust tool for the data governance policies. So enable your secure and compliant data sharing both within and outside of your organization. And the last but not least is we recognize the importance of security, and also we realize the importance to protect your personal information, your customers' information. So we supported these safeguarded policies. Now, because not all your data in the same environment as we mentioned, we will walk you through step by step what the use case you can have from data lake, data warehouse, lakehouse, data mesh, and then what the solution can be. Now, let's assume you are working for a company and you are building a data lake within your organization, and you're using a technical metadata catalog. So to make sure your data access and the permission can be managed at one place. So most important, you want easy data sharing. So different departments in your organization can work together on the same set of data. AWS Glue Data Catalog is the metadata store for data lakes. It can enable data sharing in a data lake because it addresses the challenges associated with managing, discovering, and governing the data across diverse data sets. It serves as a single data source of truth for metadata across your data lake. It enables your user to locate and understand their data set efficiently, and it breaks down the data silos. And most important, it's integrated with different other services and tools. For example, Athena, Redshift, Spectrum, EMR, as well as third-party tools. So when you are using different engines and access the data, you can have the same experience, the same data, same governance, and have your team work together. It's very easy to enable data sharing in Data Lake with Glue Data Catalog. As a data owner, you can create a resource link in your Glue Data Catalog. And this link points to the data you want to share with another AWS account. The owner at the same time can define the permission and policies, access control through AWS Lake Formation. And you can restrict what your recipient can access. From the recipient side, you will see the shared data appeared on your Glue Data Catalog, the same as other data you have. The only difference is the actual data actually still remains in the owner account. And the recipient can now query the data using the services like Athena, Spectrum, and others you want, and then you can the permission is defined by the owner. So the lake formation at the same time, it enforces the permission is granted to the right person. So all this essence of how data sharing work in the Glue Data Catalog is a secure and efficient way to share the data across account and without moving the data around. Okay, so finish the data lake use case. What if you are not using data lake, you are using data warehouse like Amazon Redshift? Now imagine you are working cross teams or business units and you want to build a joint dashboard, or you want to generate a report, you want to run some analytics, but your data in different data warehouse clusters. And now this is where like Amazon Redshift can help to share your data between different data warehouses, cross account, cross regions. So far, Redshift data sharing has already thousands of customers, and they are running millions of queries daily on shared data. So the Redshift data sharing allows customers to share live, transparent, transactionally consistent data cross data warehouse within your one data warehouse, cross data warehouse, cross region. And we see the customer, they are forming different data sharing architecture. So I'm showing two typical architecture here. The data mesh and hub and spoke. So the data mesh architecture you can have different business groups, seamless sharing and collaborating on data, and you can be either producer or consumer. On the other side, the hub and spoke structure, it allows you to bring your data in a common environment, and you can have a satellite consumers and consume the same data. So my colleague Sarva, he will explain more about the data mesh architecture in the later lecture. And to understand how the data sharing work in Redshift, there are two very important concepts. One is the provisioned work cluster and the serverless workgroup. Another is Amazon Redshift managed storage, aka RMS. So your cluster or serverless workgroup is a series of compute nodes, and it works together to read, write, analyze, and transform data. And the RMS is where we store the data. And anytime you add, remove, or change your data, and it will commit it into Amazon S3. So when you run a query, your Redshift warehouse check if this data is in the memory. If it's in the memory, then we will run your query using the data in memory. If not, we will ingest it into your warehouse from S3 and then having you to run the query. So data sharing is an extension of that. Customers, they can specify other clusters, serverless namespace, and other accounts they want to read the data. And once you add these objects into data share, you are given the permission for other data warehouse to query your data. So it right now is giving the read permission. So, but only with read, it might not serve all your use case, because what if you want to scale your ETL workload and you want to write into the data warehouse? We just announced the general availability of multi-data warehouse writes. It allows the data consumer can write into the original database. So with this, you can, if you have a very heavy ETL workload and you want to have a better performance, you want to break it into different data warehouses and they can work together, they can read and write. And the producer can control the permission who can write into my database. So this is very powerful feature that enables a data mesh architecture and also simplify your workload and make the data analytics easier. Cool. So now, what if you are using both data lake and data warehouse? You might don't want to jump around in different service to figure out how to share the data. Now, we have a new concept called Lakehouse. What is Lakehouse? Lakehouse combines the flexibility and the openness of data lakes. At the same time, the performance and transactional data management of data warehouses. So it enables your organization to choose from a wide range of services and tools to suit various analytic use cases, for whether you are doing the business intelligence, ETL process, dashboarding, or even cutting-edge technology like AI, ML, generative AI application. You can have the data silo break, and you can query the same set of data in Lakehouse. So in this week, Matt Garman just announced Amazon's SageMaker Lakehouse. And this is very powerful, and it unifies your data across Amazon S3 and Amazon Redshift data warehouse, help you to build the powerful analytics and AI ML applications on single copy of data. So SageMaker Lakehouse gives you the flexibility to access and query your data in place. With all Apache Iceberg compatible tools and engines that include AWS services like EMR, Glue, Redshift, as well as open source frameworks such as Apache Spark. And you can secure your data in Lakehouse with AWS Lake Formation with defined fine-grained permissions, and you can access, manage, govern your data in one place. The way how it works, to access Lakehouse, you still go to your Glue data catalog. In Glue data catalog, you can create databases that are logical container for your tables. Then you can choose where to store these tables. You can either choose to store your table in Amazon S3 if you want the open formats like Iceberg, or you can store this in the BI application like Amazon in RMS. And no matter where you store the data, you can access them as an Iceberg table, and you can create materialized views on the data tables to lower your, to power your BI dashboards. So in summary, SageMaker Lakehouse unifies the experience of data lake and data warehouse, make data collaboration and governance much easier compared to have data siloed in different places. Cool. Now, let's have Saurabh to talk about data sharing data mesh. Okay.
Thanks, Yanzu. Hey everyone, I'm Saurabh Bhutiani. I'm a principal big data specialist solutions architect. Let's go into one of my favorite data sharing topic, which is data mesh. But before we go into the topic of sharing with data mesh, let's understand what is data mesh. So data mesh is an emerging architecture and organizational approach for data management, which allows you to decentralize the responsibility to domain-oriented teams. Now, what does domain-oriented teams mean? Domain-oriented teams mean the people who work closely with the data, who understand the data. Like think about data stewards in your organization, right? These are the people who understand the quality of the data, the integrity of the data, and where the data should be used and how it should be used, right? So what data mesh does is, as a pattern, you want to allow your domain owners or these data stewards to be able to control the access to the data and govern the data, right? So what you are doing is essentially, you don't need a central platform data management team. Now you are allowing the federated data governance because these domain owners are the ones who will approve the access. They can decide what data gets shared with what consumer. They can even put restrictions on the data set saying that, okay, out of 10 columns in my table, I want to share only 5 columns, right? So they can do all of that. Now another thing what these domain owners will do is they will share the data as a product, right? As part of the data mesh pattern. So what is a product? Product is basically a combination of one or more data assets. So you could have one single table as a product as well, or you could have multiple tables combined together to come as part of the domain hierarchy, and you can construct that as a product. Now one important aspect is that data mesh allows you to do self-serve data platform. What does that mean is you bring together people in your organization and there is a platform. So you need to have a set of tools, maybe a web-based IDE or something else, which allows these people to come together, access the data, discover the data, and then start using that data, right? But again, they would need to subscribe to that data, and the domain owners or the data owners would be the ones who will be approving access to that data at any point of time. So that encourages the federated computational governance. So let's look at Amazon DataZone. This is a service in our AWS ecosystem that allows you to build data mesh kind of patterns for doing data sharing. Now, Amazon DataZone empowers the data producers who are producing the data and the consumers to come together in a common platform. So it's basically connecting the data people through a set of tools, and we will look a little bit more in detail in the next slide. And then it allows you to do automated discovery. It also has GenAI capabilities. So if you are a data owner, you want to generate, say, glossaries for your business terms, right, and add it to your technical data, you could use Amazon DataZone with the GenAI features to generate those business glossaries and business context and add it to your technical catalog So it's easy for anyone in the organization to understand what does that data represent before they start consuming that, right? So that's what Amazon DataZone does. So let's look at more detail of Amazon DataZone. So on the left-hand side, and I'll quickly use this pointer. So on the left-hand side, you can see that we have data producers. Now these data producers can bring data from different sources, and these could be across accounts and regions, right? On the right side, you have data consumers. They kind of come together to access the data, and they want a collaborative environment where they can not only access the data, but can also use different tools and services to be able to gather insights on top of that data. So between the producers and consumers, we have the common layer, which is Amazon DataZone, that allows to build that collaboration service. So at the top of Amazon DataZone, we have something called as domains. Now these domains you can think of as, say, if you are an organization, right, and you have like a hierarchy. Typically, every organization would have, say, different lines of businesses, right, like marketing, finance, and so on, right? So what you can do as part of Amazon DataZone domains is you can construct your organization hierarchy as a set of domains, and you can create that entire hierarchy, right? Now, once you have done that, Amazon DataZone provides a data portal. This data portal is an out of AWS console data portal. So you basically give it to your users, and they can enter in the browser and access this data portal without having to log in into AWS console at any point of time. So that is the beauty of this data portal. Now, another thing that comes with this data portal is you can integrate your corporate identity providers like Okta, Ping, and so on. So you are able to come into this data portal using your corporate credentials. You don't need IEM credentials always to log into the data portal, though you could enable that as well. There is a flexibility for that. Let's look at the next component. Like with every AWS service, we have APIs available with DataZone as well. So if you were building, say, client applications, or you're building your own dashboards or UI or something else, right? You could always tap into the DataZone APIs and do that as well. And then Amazon DataZone provides a business data catalog. So this is the core of Amazon DataZone, if I would to think about it, where you are publishing the assets, like the data producers are publishing the assets, data assets into the business data catalog, adding the business glossaries and context that I was talking in the data mesh pattern. And then the consumers on the right-hand side, they can come to this business data catalog via the data portal and then search and discover these data assets and then subscribe to them. Once the subscription has been approved by the data producer, they can start accessing that data and using that with the tools of their choice. So for accessing the data and using with the tools of their choice, DataZone provides a concept called as projects and environments. So projects is nothing but a workspace where consumers can come together and they can access the data and then use that. And then environments kind of gives you the necessary compute resources. So say if you were to use Athena or Redshift Spectrum, you would need some kind of like provisioning if needed. So that is what environments will do as part of the project, so consumers can start using those resources. And then at the bottom, you have the governance and access control. So DataZone provides these data owners and admins to kind of do governance and access controls, right? So what does that mean? As a domain owner, I can set properties on my data sets or my data products and say that, okay, what columns I want accessible by what consumers, right? What rows of data I want to be accessible by what consumers, and what other authorization policies I want on top of this data, so that only specific people in the organization can go and publish data into the business catalog, right? So if you want to do control of all of those, DataZone provides all those facilities. So let's look at how does Amazon DataZone accelerate the data mesh pattern, and I'll quickly run through the animation. So DataZone again provides decentralized ownership, and I'll talk a little bit about that. Let me quickly run through this. Yeah. So at the center, you see the domains concept that I was talking earlier. So you have the root domain that you can create for your organization, and then you can have subdomains that you can create as part of the root domain for mapping your organization hierarchy here. Once you have done that, the producers using the projects and catalog and different analytic services can come to these domains via the data portal, and then they can publish the data. Similarly, consumers can come and consume the data by discovering and searching within these Amazon DataZone domains. And another interesting thing is the producer need not be only producer. The producer itself can be a consumer as well. And a consumer can be a producer, right? So that is the beauty of data mesh, wherein you can have multiple producers and the producer itself can be consuming data from someone else as well at the same time. How many of you have heard of the next generation Amazon SageMaker? I know we did a lot of keynote announcements. Okay, I see a lot of people have heard about it. We had keynote announcements from Matt Garman, and then yesterday Swami also talked about it. Now, the next generation Amazon SageMaker, what it does is, we talked about Amazon DataZone, right? But this new platform basically brings all of your favorite services and tools into a unified experience, which we are calling it SageMaker Unified Studio, which is in public preview right now, so you can start using it and accessing it. And then it's a unified way of doing data access through the Lakehouse and using the data and AI governance as the middle tier for accessing the data in the Lakehouse. Now what Unified Studio is doing is it is bringing together various tools. Like if you have been using our AWS services in the past, right? And we have a lot of mature services like Amazon EMR, which we launched in almost like 2009, right? So it's like more than 10, 12 years old service. Similarly, Redshift launched in 2012 or something, right? So we have a lot of mature services on the data analytics and ML stack. But customers have always told us and given us feedback that we need to learn the nuances of each of your studios. Like EMR offers its own EMR studio, SageMaker has its own way of doing SageMaker studio, and so on, right? So that's where we brought all of these studio experiences together, and now you're getting one single unified studio where you can have all the different personas in your organization. It could be a business analyst, a data steward, a project manager, or it could be, say, an ML scientist, ML engineer, or a GenAI developer. All of them coming together collaboratively in this single unified studio and then being able to work on the use case for your organization. So that is going to be quite liberating for like doing different use cases. We have never done something like this. And I'm really excited about our unified studio experience. I love that experience, and I'm pretty sure you would be thrilled as well when you try it or if you have looked at any of our demos in the keynote. So what Unified Studio does is it allows you to collaborate and build faster. So you can prepare and integrate data with Amazon EMR in this Unified Studio. You can go and train and deploy AI and ML models using SageMaker AI. You can also build custom GenAI apps with the Bedrock IDE, which is also in public preview right now. And then you can run SQL queries with Amazon Redshift. And even we have facilities wherein you can schedule your notebooks, right? So if you are a Spark developer, right, or if you are an ML engineer, you created your notebook code in Python or PySpark or Scala, and you want to schedule this notebook within the studio, you can do that. So you don't need to go out of the studio. Again, the beauty of this Unified Studio is this is, again, an out of AWS console experience, and it comes with integrations wherein as an admin, you can configure external IDP providers like Okta, Ping, and so on. So you can bring in your corporate credentials when you're logging into the Unified Studio, like I talked about DataZone, right? So at any point, these people in your organization, they would not go or have access to AWS console. They can do everything within the boundary of this new Unified Studio IDE experience. Now, what is powering this Unified Studio is Amazon SageMaker data and AI governance. And if you look at the Unified Studio is at the top, and the center layer is the data and AI governance. Now, we also launched something called as SageMaker Catalog as part of the data and AI governance. And what SageMaker Catalog does is it brings together data, models, GenAI, and compute as part of a single catalog. Now, this catalog is built on top of Amazon DataZone that I was talking earlier. So we have been using Amazon DataZone from last 2.5 years with a lot of our customers. And now we have integrated and built SageMaker Catalog on top of Amazon DataZone. So all of the constructs of DataZone, if you are today a DataZone users, you can easily come into SageMaker Catalog because we are inheriting a lot of the same concepts of blueprints, domains, and so on from DataZone. Now, another important thing what we have done as part of SageMaker Catalog is we have done an Amazon Q integration. Again, it is a beautiful integration if you have looked at any of our demos. If not, then I would recommend go and try it out. What it does is, say, if you have your data published in your business data catalog, As a user, I can go and ask questions in natural language, asking it, okay, can you tell me what are the data sets which have, say, customer data? And it comes with a list of all the data assets which have customer data. You can click on it. You can look at the schema of the data. You can also look at the lineage of the data, like how is the data populated, like from the start till the end, what are the columns, if you modified any columns, did any transformations, everything is accessible as part of the SageMaker catalog. So it provides, again, more things like data quality as well. So if you are familiar with Glue data quality, then we have brought aspects of Glue data quality into SageMaker catalog. So within this unified studio, you have the catalog available to you. You can access the data. You can look at the quality of the data before even subscribing, right? So as a producer, I can publish the data into the SageMaker catalog. And then as a consumer, I can go into this unified studio, do a search, find out the data sets that will matter for me, and then I can look at the quality of the data, I can look at the lineage of the data, and then I can go for doing a subscription to that data and using it from there on. So we have, again, guardrails available, like as a producer, when you are sharing this data into the catalog, similar to DataZone, you can set up data filters saying that what columns, what rows, how you want to share this data, so that consumers only get access to those specific elements in the data, not the entire data. So if you had, say, a table which had 10 columns and 5 of them were PII, you could say that, okay, I want one version of this data shared without PII columns. So it gives only access to 5 columns to the consumers. And then for some consumers in the organization, you can make all the 10 columns available. So you can publish like 2 versions of the same data with different aspects as to who can access what from the data set. Again, what we have done is we also do auditable audit and cost logging and monitoring as part of the unified studio. So everything that the users are doing within the studio, everything will be tracked and logged as part of the CloudWatch logs. And then as an admin or a platform admin team, if you want to understand from the audit perspective, like what is happening, what actions did users take, everything will be available to you. Again, the studio brings a concept, something which is called as a project, which is like an high-level abstraction, wherein you have access to the data that you need to work with, the compute resources that you need to work with, your code or the scripts that you are working on top of this data. And then lastly, the most important part of the solving a use case is people, right, who are going to be working on this use case. So basically, the project encapsulates all the people coming together from different teams in your organization, like maybe a data steward, project manager, quality control person, or a ML engineer, business analyst, and so on. All of them can come together into this project umbrella within the unified studio, and then they will have access to the data, compute, and code in a similar fashion, in a seamless way, so they can collaborate and work in real time to work on the business use case. So with that, I will bring in Jamie, who will talk about Occidental Petroleum's journey into using DataZone and data mesh and how they're leveraging AWS services. Jamie, over to you.
Thank you. Well, howdy. Thank you, Saurabh. So I'll answer the first question you probably all have. You saw the big cowboy hat and the headshot. You see the giant AWS belt buckle. You see the boots. And yes, I am from Texas. So I am the strategic advisor for data and analytics for Oxy, and we are located in Houston, Texas. We have operations in the Middle East, in Africa, North America, Latin America, and we are over 100 years old. At Oxy, we have 3 core operations that we operate under. First is our performance production, and we produce vital energy to sustain people by continuously enhancing the safety and efficiency of our high-performance oil and gas assets and innovating to advance global sustainability. Our goal is to provide reliable energy now and in a net zero future. Our second core competency, or core operation I should say, essential chemistry. We are a world leader at Oxy in essential chemicals. We improve lives with indispensable products used in water purification, pharmaceuticals, construction, and other critical industries with a commitment to safety and quality. And our goal is to sustainably manufacture the fundamental building blocks for life-enhancing products. And finally, why I'm probably here today is carbon innovation. This is our newest core operation, and we had an opportunity to really innovate and build something new. And we partner with AWS to do that. And with our carbon innovation, we are advancing carbon capture, utilization, and storage and carbon removal technologies for sustainable carbon dioxide reduction, including what we're very excited about, a first of its kind direct air capture facility in the Permian Basin in West Texas. And our goal is to reduce our own emissions and help others do the same. So these are the three core operations we do at Oxy. So let's kind of move in to where we were and kind of still are at Oxy in some ways for our data platform. And it's probably where a lot of you are as well. We have an on-premise data warehouse. If you look from the left, all our sources, relational, structured data flowing into an on-premise data warehouse in a relational database. And it's used mainly for BI and reports, visuals, analytics, applications. It's about 30 terabytes. We have over 2,000 apps, people, and processes who hit this database every day. And so there's a lot of activity. It's very large. And with that comes some challenges. So you all probably are familiar with on-premise data warehouses. You probably have them, you're using them. Limited scalability, these are, can only go as big as the server you run them on, right? And so we can only scale so much. Maintenance burden. We have to upgrade the database. We have to upgrade the OS. We have to maintain the hardware. We have to take downtime when we do that. And so there's all those challenges with that. At Oxy, we generate a lot of unstructured and streaming data, with something that a relational database really isn't built for. Definitely not built for unstructured data and streaming data, the scale at which we bring in. We have over 2 billion data points just in our oil and gas operations a day that come into our time series databases in-house. That just would blow our relational database scalability out the water. And then, limited flexibility with Gen AI and AI and ML projects coming on board. The data warehouse isn't the best place to do that. It's really good for queries and reporting and things like that. But when you have data scientists and users doing full table scans of your 2 billion row table, the people using them for applications and reports get a little not happy, because it starts affecting performance. And so what did we do? Well, we partnered with Amazon and we adopted AWS as our cloud provider. And we built the Oxy Data and Analytics platform. That's the logo up there on the top right, also on my shirt. If you're wondering what that little creature is, that's an O-copy. You can see me after the presentation while we pick that. But it's a data mesh. And if you start from the bottom and go up, you have the data coming in to our data mesh in the AWS cloud. You have source systems, your typical relational databases for your applications and for other things. We have a lot of devices. Imagine operating in oil and gas, operating chemical plants, operating our direct air capture facility, which can generate a lot of data, a lot of devices and sensors around that. We use Apache Glue Airflow. We also use Kinesis and other services to get that data flowing into our producer domains there on the bottom, our accounts. We have 13 producer domains, and just highlight some core services in those producer domains. S3, of course, for the data lake. Redshift for the data warehouse, get the data lakehouse. Like I said, we generate a lot of time series data coming off of sensors. And so we have AWS IoT Sitewise to capture that data, which is really nice because there's also S3 cold storage behind the scenes that we can do analytics and things on. And then also DynamoDB for certain things. So all that data comes into our producer layer. In the middle, we have Amazon DataZone managing the governance. It catalogs all the data in our producers, gives us that technical catalog of our data, provides the publishing up to the consumer layer with all the access and controls for users to be able to go and use that data up in the consumer layer. And it handles, the nice thing about DataZone that we really, really liked, and we purposely kind of delayed a few months so we could use DataZone so we didn't have to do all the lake formation and data sharing ourselves. And Redshift, DataZone does that automatically for us behind the scenes, which was very, very nice. And that the DataZone shares it up to the consumer layer. And the consumer layer is where the users come in and consume the data. And they can use their BI tools they're familiar with that can connect to Redshift and Athena through S3. We also have S3 there for experimentation in SageMaker and Bedrock. So our data scientists and such who need an area to put some data to work with and experiment can do that as well. And so that's an overview of our, what we call Oxy's data analytic platform, built on a data mesh. and some of the key services that make that happen. Just to give you kind of an idea of what our data mesh looks like from the data domains inside of it. At the producer domains, these aren't the exact names, but if you kind of look, we have finance and operations and HRM and HSE. So we have domains that are at the enterprise level, so like our finance data, our HRM data, our HSE data, our midstream marketing data. They have their own domains. Then we have operation domains for those 3 core operations, the essential chemistry, the production, and the carbon. And then the domain X there on the bottom right, that's other things. So like inside of our businesses, we have like drilling and completion for oil and gas and for other things. And so, like I said, there's 13 of those producer domains. The data comes in. And then the federated governance layer. We get the business data catalog, the data portal through DataZone, data projects, all the things that DataZone gives us. That was really a key thing that helped enable our data mesh at Oxy very easy and seamlessly to our users. And then you have consumer domains, which you saw earlier. And what are the advantages of that? What did that give us? Cloud scalability. With S3, we have unlimited scale for our data coming in. With Redshift, much more capacity to scale up our data warehouse for reporting and analytics. Democratized data access and a data catalog. Users can come in and use that data, get self-service through the data catalog. In DataZone, we also have another data catalog that's a business catalog that connects to DataZone and gets all the data as well. And they can go see the data that's there, go and use it, and use the portal to go and get that access, which is very, very nice. Flexible data stores and tools. One of the challenges we had with the on-premise data warehouse, it's a database, right? It's meant for what it does, transactional, data warehousing queries, not for analytics, not for ML, not for Gen AI, right? That data sits on-premise. Technically, it sits in EC2 and AWS as of about a month and a half ago, but it's still not as easy to use for things like AI and ML as S3 sitting in the cloud that's sitting right next to the tools you want to use like SageMaker and Bedrock for Gen AI. Flexible data stores and tools. And the one thing we're very, very excited about, as you saw announced, and Rob just talked about this, is the Amazon SageMaker Unified Studio. We got to see previews of that and look at it and work with it. And we're very, very excited. And that's one of the things when we go back and we're going to work on is getting that experience to our users so that the tool, the query editors, the SageMakers, the catalog, the data catalog is all in one tool for that unified experience. A decentralized architecture. Now, with the data domains, the data owners and the experts that know that data best can work in those data domains to get that data in those data domains, manage who has access to it, and use it. And then federated data governance. In fact, our data governance person, our IT, is here today, and we have controls at what you think like a federal government level, right? That they set across the domains, like these are the naming standards, these are things we're all going to follow. But at the individual data domains, you have data owners and things that can put that data where they need it and how they need it. And so it's really been, the data mesh has really been nice. And AWS has been really key with all the services, and having them all together and how well they integrate has been key for enabling Oxy to do that. So what have we done? We've built the data platform. What have we been able to do with this ODAP, this Oxy Data Analytics Platform in AWS? I just picked one tool that kind of covers a lot of things to kind of show and talk about what we've done. And we have a tool called Delta Cipher. It's part of our Delta initiative. It's a team within inside Oxy that works on advanced technologies and things and innovations around drilling and completions. And they built this chatbot-like experience in Teams where engineers can go in and, leveraging Gen AI, provide instant natural language access to operational insights. And they can translate queries of conversation into queries to query tables in ODAP. So the drilling data that's sitting in ODAP, they can through an agentic AI, issue the natural language. That agentic AI, that Bedrock agent, can convert that to natural query language, SQL query, and get back those insights. And it accelerates multi-well analysis without complex query formulation and manual data aggregation. And so what does that last statement mean? It means that our drilling engineers don't have to spend all day querying this database to this report, go look at graphs and pull the insights out of those graphs, go look at Teams chats for all this stuff, and then spend all day and come back and say, hey, what happened with this well? at this time, they can go in and do this. They can go to Delta Cipher and say, hey, how may I help you? Provide a summary and list any issues or problems for a well, XYZ. Also explain why did they POOH, pull out of hole. And that was at 10:40 a.m. And you can see at 10:41 a.m. I don't think it really took a minute. It just probably did it the last part at 10:40 a.m. It gave them all this information, and it looked at Teams chats from the drilling engineers and the people drilling in the field that's loaded into ODAP. It looked at drilling data that's in our ODAP, in our data lake, using Athena. It looked at, we use Claude to take images we get from the drillers that have different values. Claude took those images, and those images are graphs, and it converted them into tables, into data tables, and loaded that into ODAP. And we're able to use that, because we only get those as graphs. And now as data tables, and they can go in, and they can get all that insight. It can look at, millions of rows of drilling data, hundreds of chats, and all these charts, put all this together in less than a minute. And it's something that may take a drilling engineer a day or two to do, right? So very, very valuable. So what's the architecture look like? A lot of you are probably nerds like me. You're like, how did y'all do that? So if you start at the top left, producer, we have the data coming in to our producer layer for drilling and completions. We have Teams chat data, we have the drilling data, the actual data that we get from the drilling. We have those charts I talked about. All that data lands in our Amazon S3, and DataZone makes it available into the consumer layer on the bottom left. And then from the bottom right, users can go into Teams, initialize Delta Cipher, uses API gateway, call a Lambda function, use the Bedrock agentic AI agent to make the call, get the data, and get back the results. So what's next for Oxy? So we built, we've been working on this for probably about a year and a half with ODAP, and domain. So some of the things we got is some of the new features that have come out with DataZone, like domain units. So implementing domain units, that's one thing we're gonna start working, actually we are working on, not started, we are working on it, defining those domain units. So you can think of domain units as subdomains of your main domains. Data products, not data products in the term of what data mesh says data product. Well, it is data products in that term, but in DataZone, they have a feature called data products where you can take individual data products, group them in together as one data product. So for like an example, if you have GL transactions, you have the actual transactions themselves, you have all the dimension data like cost centers and all that make up. You can put that together as one data product called GL transactions. Fine grain access, using fine grain access in DataZone to limit the rows and columns that people can see. And then data exchange. We're actually looking at pulling some data from Standards & Poor's through data exchange. So Rob will talk about this in a few minutes. And this is what we're working on next. And again, like I said earlier, Amazon SageMaker Unified Studio, that's a big one on the list for us. So some lessons learned. We've been on this journey for about a year and a half now. Perfect is the enemy of good. You probably already heard that. And I'll say, as you're building AI applications, ML applications, there's no such thing as a perfect one. You've all probably used chat boxes and things before. They're not always perfect, right? And so as you go through and you build your AI and ML use cases, and you go through and you build your agentic AI and all those things, know that they're not always going to be perfect, but you don't wait till they're perfect to use them. But then also, as we were building out the platform, there's people in the room, and we're deciding how many domain units we needed. I told you earlier we had 13. Well, we had 11 up until about a month ago. And we needed 2 more, right? And the nice thing about the platform is it's flexible enough that if you don't might quite get it right the first time, you can pivot and you can change and you can add domains. And as you come with naming standards and things like that, you had people that want it this way, people that want it that way, and at the end of the day, we had to just come up with one, right? And not sit there and spin our wheels. Data mesh org changes require consideration. Data mesh is not just technology. It's actually a fundamental way of thinking different, right? With traditional data warehouse, you generally had a central group that built that data warehouse and loaded the data in there from business requirements. With the data mesh and with the flexibility you get with data domains and with all the flexibility we have a tool that can allow end users to even load data. You got to think about the org change and how that governance works and how the functional teams you're going to set up for each data domain will work. And so as you plan your data mesh, don't just think of the technology, think of how you're gonna have to work with the business and with other folks in IT to make that data mesh work for governance and data quality and things like that. Don't lose sight of business outcomes. Most of you probably are technical IT folks in the room. Just remember at the end of the day, all your design and governance efforts should be around your business outcomes, right? Platform implementation transparency is valuable. We had lots of teams working on this, and we have several consulting groups we work with to help us out. We use IAC extensively, DevOps extensively. Everything is done through IAC. All the code is checked in to a Git repo, and all the teams work together, have access to what they should have access to. So if they want to build a pipeline to load data, they can see how that works because it's all standardized and set up so they can go use that for what they need to do. And then task parallelization can work against progress. One of the things is you can do a lot when you set up this data mesh and start loading. Just don't overload and over parallelize your work streams getting data in. One of the things we did is we started what we call the golden data flow, and it was our GL transactions data. We did just that one first so that we can get all the other lessons that we needed to learn, so that before we started the other ones, we didn't have 8 of them going at the same time and then realize, oh wait, we should have did it this way. Now we had 8 of them to go back. We did that one, it was the golden, we got it into production, we made sure it was good, we took the lessons we learned from that, and we were able to apply that to all the rest of the work streams. And so with that, I'll turn it back over to Saurabh. But again, AWS has been really, really a key enabler, and it's really allowed us to really take our data and analytics to the next level. And with the things we're doing with the DAC and with our oil and gas production and our chemical, it's really helping us move forward a lot. There you go, Saurabh.
Thank you, Jamie, for walking us through the amazing use case that Oxy built with the help of DataZone, data mesh, and the whole chatbot thing. Okay, so till now, I think we looked at everything that was needed for doing data sharing with the first-party data, right? Like if your data is always in AWS and you're sharing between your accounts, between the producers and consumers, within your AWS organization and so on, right? But obviously, you will have some use cases where you would want to do third-party data collaboration as well, right? And let's look at what are the options available for doing data collaboration there. So the first one is AWS Data Exchange, and this service offers 5 different ways to license third-party data faster and easier, right? So if you have data from maybe a data provider that you want to license and use as part of your projects or your organization, then you can look at using AWS Data Exchange. On the left-hand side, you can see that there are multiple options. Like one is you can use AWS Data Exchange for data files. What this does is you can automatically export new or updated data into your Amazon S3 buckets, which saves time and effort in exporting the data, and you don't need to manage complex development pipelines or data pipelines, right? Now, as part of these data files, you can not only have the text data, but it can be data which could be in different formats like images, audio, movies, and so on. And you can use all of that from the data providers who are licensing this data. And then once you have the license, you can use them and bring into your own S3 buckets and use them from there on. Once the data is in your S3 buckets, you can use a lot of our native technology and services for analytics, ML, and so on to build on top of that data. Next is we have AWS Data Exchange for Amazon S3. As part of this, you don't need to even move the data or copy the data. If the data provider has data in an existing S3 bucket, they can just license the data from there. And once you have the license and subscribe to that, you can seamlessly access the data directly from their provider's S3 bucket. We also have an option wherein, say, if you had data which is in the tabular format or structured SQL format, right? How do you go about licensing that and accessing that? So for that, there are 2 more options. One is AWS Data Exchange for AWS Lake Formation. So as part of this, the data provider, if they already have, say, tabular data, they can enable lake formation permissions and fine-grained access controls, and then they can license the data to you, and then you can start accessing from there on. So you get access to the live tables which are sitting in S3, in a tabular format and start running queries on top of it. Similarly, we have AWS Data Exchange for Amazon Redshift. So if the data provider had the data already in their existing Redshift clusters and warehouses, they could enable licensing on top of that using AWS Data Exchange, and then you can go and subscribe to that data, and then you can directly run queries on top of those Redshift data sources from your Redshift warehouses. Finally, we also have an option wherein, say, if you wanted to use third-party APIs, right, and find them, discover them, and then license them, we have an option called as AWS Data Exchange for APIs, wherein once you have licensed those APIs, you can start making calls from your applications and start using them for building whatever you want to do. All right, so this is all good and great, but what if I wanted to gather insights from my data, plus I wanted to use all the data that exists in the marketplace out there without exposing my underlying data? So I don't want to expose individual rows of my data, but I still want to gather insights, right? So think about an example where, say, I am an advertiser and I have advertising data for my customers coming on my website, but I want to augment this with data coming from, say, multiple other advertisers. Maybe it is YouTube, Google Analytics, Amazon Ads, or something else, right? How can I do that without exposing my customers' data, underlying rows of data, but still being able to gather insights? So that's where we have AWS Clean Rooms. This allows multi-party collaboration without sharing the underlying data. So this is also a concept which we call as differential privacy, wherein you are not exposing your underlying data, but at the same time, you are able to bring all the data together and gather insights and do more things on top of that, right? Another important part, there is no AWS data movement, right? So whoever wants to use Clean Room, they can onboard their existing S3 buckets and bring them into Clean Rooms, and from there on, multiple people who are coming together or multiple parties coming into that Clean Room can access the data and gather insights. Now, how do you prevent the consumers to not have access to the row level data, right? And for that, Clean Rooms provides something called as query controls and enforcement. So when you are onboarding to Clean Rooms, you can say that, okay, on top of my data, I only want queries like aggregations, percentiles, and so on to run. And you cannot do like a select star and do a limit to see the underlying data. So what that does is, everyone who is collaborating in that Clean Room can only run aggregation queries to gather insights, but they cannot reach out to the row level data or the low level data. So that is the beauty of Clean Rooms. Again, Clean Rooms uses cryptographic computing. So it uses algorithms to make sure we have encryption in place when the data is sitting in rest, or when you are transmitting the data, right? If it is in transit as well, it can use algorithms and encrypt the data. And finally, Clean Rooms provides programmatic access. So you can use APIs as well. Like we have a console experience and a dashboard out there for Clean Rooms where you can go and run queries, SQL queries directly on top of data from multiple parties. But if you were to build, say, maybe a custom application in-house, right, you could always do that. And for that, we provide the API-based programmatic access. All right, so I think we learned a lot today. We covered a plethora of use cases. So based on your use cases, we have a solution for you in AWS. We also looked at the next generation of SageMaker, which has the beautiful unified studio. Again, go and try it out for yourself. That kind of helps you to bring all of these pieces together in some way to do the producer-consumer model, and then being able to use the catalog, business catalog, to along with generative AI to access the data. So thanks again for joining us and attending this session. Please make sure to fill out the surveys in your mobile apps, and we would expect nothing short of 5 out of 5. If you are not happy and going to give less than 5, please talk to us outside of the conversation, and we are happy to answer any of your questions. Thanks, everyone. Wish you all a wonderful day and a great rest of reInvent.